Assalamualaikum. Welcome back to my YouTube channel. So today we are reviewing our beautiful project of line follower of MES phase 3. So first of all, what is actually a line follower? So a line follower is a device or is a robot that can follow a line with the help of the multiple sensor. So the our aim of creating a line follower robot, not just a line follower robot, but it is also able to detect the obstacle it tackle along with its journey, or the color of the obstacle it face in its journey, as well as able to store its current data, its voltage and current rating on the SD card, as well as display it on the OLED display as well as on the cloud. So these are the some features and characteristics of our Rehbar. So we use a 5 IR sensor array and the ultrasonic sensor encoders, which is we use the Hall effect sensor as a on encoder, and the double motors and IR micro SD card, as well as some ESP32 for the cloud display. So the components we use is the Arduino Mega. The Arduino Mega we use is a central processing unit, which is a main brain of our Rehbar robot, as well as we use a OLED display, which is able to display the voltage and the current ratings and the turn data and the color of the obstacle it faces along its journey on the screen. As well as we use the L29N motor driver, which is used to drive the motors, and the IR sensor array. We use the 5 channel IR sensor array for the accurate detection of the line, as well as N20 motor because it is a very fast motor, and the ultrasonic sensor to detect the obstacle, as well as SD card module to store the voltage and the current rating and the turn data on the SD card, as well as Hall effect sensor. We use the Hall effect sensor, which is providing us the same purpose as an encoder. These are the some project development process. This is our initial block diagram in which we gather all the inputs that we need and the output that it provide. We have the IR sensor as an input and the color sensor as an input. We use as an ultrasonic sensor as an input and the voltage sensor as an input. We use current sensor as an input, and in output we get the display. We get the data on the display screen, and on we the storing of the data on the SD card and L29 and motor driver. There's some literature view of the component. We use the Arduino Mega for its higher durability, and it's a lot number of pins. We use the IR sensor that I explained it earlier for the right accurate movement of the line, accurate detection of the line, as well as the color sensor for the detecting the color of the obstacle, and the ultrasonic sensor for actually detecting the obstacle, as well as the SD card module for storing the voltage current ratings and the turn data on the SD card, an OLED display to display all of the necessary data on the display, and ESP32, which is serially connected with our Arduino Mega, and it is able to display the current and voltage rating as well as turn ratings on the ThinkSpeak cloud. The motors we use is the N20 motors, and the motor driver which is used, we use the L298 motor driver mini, uh, and the wheels for the N20 motor, the PCB board, as our sir told us to make a rubber robot on the PCB. So we use a PCB board as a chassis. Headers for the PCB, and the battery and the switch, as well as buck boost converter and voltage sensor and the current sensor. The chapter 3 is about the mechanical design. For the mechanical design, we use the PCB fiber sheet to make our Rehbar robot. And the chapter 4 is all about the software design. For the software, first we use the ATmega. It's IC ATmega 2560 because it has a more pins, and it's because of its processing power, compatibility, and USB connectivity, as well as its disadvantages that it's larger in size and power consumption is a disadvantage. The state machine, this is the state machine for the initial line follower that has two IR sensor or two sensor for the detection of the line. So this state machine state that this is the state for the wait, and this is the forward state, and this is the left and the right state. When multiple logics come, so it do its function accordingly. This is the state table of the above state machine. And after that, this is the detailed block diagram of our project, that we have all of this input that I explained you earlier and the output. And I show here there are the two motors which L298 motor driver moves, and this Hall effect sensor which is working same as an encoder, as well as this ESP32 which is serially connected with our micro controller to display the data on the cloud. After that, the chapter number 5 is the simulation and the testing of the components. Before going on the hardware process, we first tested each and every individual component on the Proteus software, and here are some snippets. The ultrasonic sensor, we also test the IR sensor and motor driver, as well as display and voltage and the current sensor on the Proteus software. After that, the next thing is to program our Rehbar board. So for programming, we use the Arduino IDE software, and this is some file links that we have already provided in this Word document, as well as I also provide this code link in the link of this video description. The chapter number 6 is all about the system making and the testing phase. So this is our requirement, which is the list of the components and the input that we are using, which are the sensors as an input, and the output what we are getting. And this is our PCB design. In this video, I will give you a detailed explanation on this PCB design. After that, we have the PCB manufacturing. So this is our final Rehbar structure, which is looks like this. And the chapter 7 is all about the status. So the status of the overall project is a success, and its battery timing is all about the 20 minutes, and its speed in centimeter is 21.3 centimeter per second. It covers 21.3 centimeters in per second, as well as in speed in meter per second. And the cost analysis of the overall project, the cost of the overall project is all about 20,000. And the word count for this, and what we challenges face, I already mentioned the challenges we faced during the making of this Rehbar report, and what we will do in the future, as well as finding and analysis, the result and discussion. The output of the Rehbar report is accurate, and the conclusion of overall project. Now I will show you the design of the Proteus. So this is our Arduino Mega, and this is our some headers for the OLED display, and this is the header for buck boost converter, voltage and current sensors, as well as it is some headers for the ultrasonic sensor as well as color sensors, and this is some headers for the IR sensor, and this is some headers for the original color sensor to fit on, and this is some headers for the current sensor, as well as we have the two more headers for the motors in pins, as well as the encoder pins. So it is our PCB layout of the Rehbar. After that, this is the practical demonstration of our video. So this is our first working video, and this is our second as we look closely, these are the Hall effect sensor that's serving as an encoder. And these are the current and the voltage ready that were shown on the ThingSpeak Cloud by ESP32. As well as if we look at the code of our Rehbar, So first we have some necessary libraries for the OLED display and for the SD card, as well as some necessary parameters or necessary variable that we are using in this code, as well as we write some code for the OLED display to initialize, as well as these are the some pin modes that we are using in this whole wrapper. That these are the some pins for the color sensor, these are some pins for the motor driver, and these are the some pins for the ultrasonic sensor as well as for the motor driver. And these are the some interrupt pins, two interrupt pin that we are using for the hall effect sensor that is used that is serving the role as an encoder, which is giving us the rotation of the wheels. As well as there are some commands about the SD cards and displaying the data. You find this code in the link in the you find the code link in the description of this video, as well as these are the some logics that the Rehbar is working on, and the ultrasonic sensor function and the current sensor function and the voltage sensor function and the color sensor function. I make different function for all of these, and some encoders functions, I mean Hall effect sensor functions and the stop function. These are the main Arduino Mega code, and this is the ESP32 code which is serially connected with our Arduino and sending the current and voltage and the current data on the Thixby cloud. So this is our detailed Rehbar report. Hope you like it, and Allah Hafiz.